All right, welcome back to our video series. We're talking about Chapter 3. This will be our first video for Chapter 3. We're starting with Lesson 3. And the main reason is to kind of get you guys used to doing some stuff with the algebra skills that it should be a little bit of a review, but there's still some confusion about some of these big ideas with slope. And so we're going to talk about that in this first lesson. It should be pretty short. We'll go from there. All right, we will take a look here. I want to again make use of something that I've done in every one of the videos, or at least most of them, but I want to point some things out to you guys. What I want to do with our objectives for each video, each lesson, is I really want to make sure you're understanding how I tie this into stuff we've done before, or stuff that you might have seen before, what we're going to do now, and then how that eventually will tie into stuff we do in the future. All right, so in the past, we've talked about parallel lines. This is a little bit skewed because it refers back to lessons 1 and 2, which we haven't actually learned yet. But we did determine congruent angles. We've talked about those things. We've talked about parallel lines in the past. And so now what we're going to use, we're going to talk about slopes of lines, and we're going to use those to identify parallel and perpendicular lines. This is a big idea, identifying parallel and perpendicular lines using the concept of slope. And once again, these are things that you've done before in Algebra 1, but I want to make sure that we are still remembering how to do that. And so we'll come back to this page in just a little bit. All right. So one of your first big key concepts and something that's printed on your note packet is this idea of what slope is. In the coordinate plane, the slope of a line is the ratio of the change, or rate of change, along the y-axis compared to the change along the x-axis between any 2 points on the line. We talk about slope as the letter m. We represent slope with m. And these x1, y1, and x2, y2 being the coordinates of 2 given points, we get this slope formula. And again, this is written in your vocab, but it's also really important. Make sure you highlight, underline it, or put a box around it so you know what that looks like. And once again, it's printed here according to the graph. Okay, we do call slope rise over run, but this formula is the important piece that I want you to remember and take away from this. So, when we talk about these rates of changes, these slopes of lines, there are 4 distinct possibilities for any given line. So let's say this is our line. Okay? This line rises as it goes to the right. It goes up and to the right. That means it has a positive slope. Every numeric value we get for this slope would be positive. But when it descends or goes down and to the right, that means that we get a negative slope. Now, if it doesn't go up and to the right or down and to the right, there are 2 other possibilities. This line is what we would call horizontal. The line is described as horizontal, but the slope is considered to be a 0 slope. Okay? And then this line is what we'd consider to be vertical. Goes up and down. There is no run here, it's all rise. And so this is what we consider an undefined slope. We don't give a numeric value, we don't say it's 0, that's horizontal lines that have a slope of 0. But a vertical line has what we consider an undefined slope, and that comes from when we try and do our rise over run, and we try and divide by 0. There is no run here, there is a 0 value for the run. Dividing by 0 gives you an error when you put it in your calculator, and that is because that is an undefined mathematical process. It is impossible to divide by 0. Okay? So we're going to practice this idea of slope using a graph and just using the coordinates on a plane. Okay, these 4 line up with our graph. And so first we're going to take a look at line AB. Okay, you should recognize that is a horizontal line, so automatically we can say that that slope equals 0. Okay, so we don't have to do the calculations if we recognize from the previous page. It's a horizontal line. There is no run. Okay, or I'm sorry, there is no rise. There is a run. Okay, we would have a rise of 0 and a run of 1, 2, 3, 4, 5. 0 divided by 5 equals 0. Okay? But next, let's actually look at a line that requires us to do a calculation. So AC is that line, and we want the slope of that line. And so what we're going to do is make a slope triangle on this graph to compare rise over run. Let's pretend for a moment that we're just going to start with A and go towards C. That's going to give us some directions. So we're going to start at A and go towards C. My rise then would have to be a negative value. I'm going to go down 1, 2, 3, 4, 5 units to get to the Y value for C. So that's a negative 5. And then we're going to go to the right, 1, 2, 3, 4, 5, 6. Be careful in how you count. We count the spaces and we don't start with the line. So our rise over run ends up being negative 5 over 6. And that fraction will not reduce, so that is your slope. Negative 5/6. Okay, let me see if I can zoom in a little bit. Make this a little bit easier to read. I want you guys to try and find the slopes for part C and part D. Find the slopes of line AD and line CD. Again, highlight those individually if you need to. Alright, if you need more time, go ahead and pause the video. Otherwise, these are the answers you should get for C and D. Line AD is a vertical line, so it has an undefined slope. Again, if you tried to calculate that, your rise would be either negative 6 or positive 6, and then your run would be 0, which is undefined. We can't do a divide by 0 situation there. But on CD, if you choose to start at C and go back to D, you're actually going to go down and to the left. Down and to the left is a negative over negative, which is the same as going up 1 to the right 6, which would be positive 1/6. Alright, so for finding slope using a graph, you can just kind of count the spaces. Otherwise, you have to use the slope formula. And I'll write that for you here in case you can't remember it, where we take the difference of the two y values and divide that by the difference of the two x values, making sure to keep the same order. So for our slope between these 2 points, from 3,6 to negative 2,5, 3 is considered your x1, 6 is considered your y1, negative 2 could be your x2, and y would then be your y2. So when we find our slope, we're going to start with y2 on top, 5, and subtract y1. And then on the bottom, we're going to put the negative 2 first and subtract 3. And then 5 minus 6 is negative 1, negative 2 minus 3 is negative 5. Remember that a negative divided by a negative is a positive, so our answer is 1/5. The slope between these 2 points is 1/5. I want you guys to try and do that calculation using this formula for part F. Again, be careful of your negative and be careful of your 0. But go ahead and plug in those values and simplify your slope for part F. And so that you have enough time to do this, pause the video, and when you are ready, I'll show your answer. Alright, if you need more time, pause the video, otherwise this is what we should get. Negative 2 over 11. We would do 0 minus 2 on top, and then 7 minus negative 4, which really becomes 7 plus 4 in the bottom, and negative 2 over 11 is the result we get. Alright, for this next example, I'm going to read this to you and then we're going to talk about what it means in terms of this graph. Justin is driving from home to his college dorm. At 4 p.m. he is 260 miles from home. At 7 p.m. he is 455 miles from home. We want to graph the line that represents Justin's distance from home at a given time, and we also want to find and interpret the slope of that line. Alright, and that essentially gives me two ordered pairs. At 4 p.m. he's 260 miles from home, so this y-axis represents your distance from home, 0 being home, 700 being the furthest possibility away from home. And the x-axis represents the times after noon. Okay, this would be 1 o'clock, then 2 o'clock, 3 o'clock, 4 o'clock, all the way till 10 o'clock in the evening. So that 0, 0 represents noon and being at home. All right. So what we want to do is plot these 2 points on the graph, which should look something like this. Over to 4 o'clock, and then go up to 260, which is a little bit past halfway between 200 and 300. And then at 7, it would be, again, just barely past halfway between 400 and 500. All right, and then we could connect those and graph the line representing his travel. All right, and that works out this way. Now what we want to do is find and interpret the slope of that line. Now we do not want to try and count like we did in our first few examples up here. We want to use our formula to calculate that slope, because these are not going to work out nice and neat because of the grid that we've chosen. So to find the slope, we actually want to calculate that, starting with 455 minus 260 on top, because those are the y values. Then we would do 7 minus 4 on the bottom, giving us 195 over 3, which simplifies to 65 over 1. Now what these are comparisons of are miles units over hours units. And so 195 miles per 3 hours simplifies to 65 miles per 1 hour. So our unit of measure is actually miles per hour, which you guys should recognize as a speed. That means that this measurement of slope or rate of change is a speed measurement. It's his average rate or average speed traveling from home to his college dorm. All right, and this brings us to one of our other big key ideas here when we talk about parallel and perpendicular lines. And here's the basic idea. Slopes of parallel lines are the same. Two lines having the same slope are parallel. Okay. Slopes of perpendicular lines have a product of -1. Our key idea here is the phrase opposite reciprocal. Okay, slopes of perpendicular lines are opposite reciprocals, like 4 and -1/4. Okay, two numbers that multiply to a product of -1 are considered opposite reciprocals. So we could have 2/3 and -3/2. Or we could have 5 and -1/5. Or you could have -10 and +1/10. Those are all examples of opposite reciprocal slopes. Okay, and these would be slopes of perpendicular lines. So remember what perpendicular means. It means that two lines intersect at a right angle. Okay, and so there's that information. Now in order to continue forward, we're only going to cover part of this in the video. The rest we'll cover in class. But what I want us to do is finish filling this part out, and then we'll cover these examples in class. So if a line has a slope of a over b, then the slope of a perpendicular line would be the opposite reciprocal of that. It would be -b over a. Reciprocal means you flip the fraction. If a line has a slope of a over b, then the slope of a parallel line would be still a over b, the same thing. Parallel lines have the same slopes. So the ratios a over b and -b over a are again called opposite reciprocals. Okay? And so we're actually going to use these ideas and these concepts to finish out your examples for this lesson. But that part we'll do in class so that our video doesn't end up being quite so long. Explained a lot here, but I do want you to remember this key idea. Okay, we found slopes of our lines in this lesson, and we're going to use those slopes in class to identify parallel perpendicular lines. All right, make sure you bring this back so we can finish these examples in class.